Time fills our lives and each and every moment of the history of the universe. But what time really is a question still to be answered. Nonetheless, there is something that we know about time. For example, we know that time is not absolute, it is relative. It's not the same for everyone. It flows at a different rhythm for different persons and objects, and its pace constantly changes, slightly, but certainly. It was revealed in 1905 when Albert Einstein demonstrated that the time for a moving object flows more slowly compared to an observer at rest. The higher the speed, the slower the rhythm at which time passes. So, if we have two identical twins, for instance, and one of them starts a journey into space, let's say at 96% of the speed of light, upon his return, 50 years later, he will be aged a lot less. 10 years. This is not just a theory, it's reality and it has been proved over and over again. But how can it be possible that in a universe where to any action corresponds an equal and opposite reaction, an object now moving gets older more slowly than before, and nothing else balances this effect? We should expect that if the astronaut's time begins to flow more slowly, somebody or something else's time must begin to flow faster and compensate it. Still, Einstein didn't explain it, nor does it any other book. And yet, there is indeed a simple explanation. There is something that gets older faster than normal. The engine, the fuel, and all the parts of the rocket that allow the astronaut to accelerate and gain speed got older and wasted performing the work. They transformed their internal energy into the astronaut kinetic energy. The result is that the astronaut obtained more energy and his time started to flow slower. Vice versa, the engine and the fuel lost energy in the process and got older. So, the higher the energy, the slower the rhythm at which time flows. Extending Einstein's idea to include any type of energy has profound consequences in the way we observe the universe around us. The second law of thermodynamics says that energy flows from hot to cold systems. Thus, the cold interstellar space continuously receives energy from the hotter stars and planets, and its energy increases. Then, if we assume that whenever the energy of a system increases, the rhythm of its time slows down, we have to conclude that time in space is slowing down. As a result, the light emitted by stars and galaxies traveling through space takes longer and longer to reach us, as if we were watching a slow-motion movie. However, we know that light always travels at the same speed, as a car that runs at 100 km per hour no matter what. If that car then takes 1 hour to get to us, we assume that it was 100 km away from us when it started its journey. If it takes 2 hours, 200 kilometers, 3 hours, 300 kilometers, and so on. So, in a universe where stars and galaxies are fixed, but the energy increases and the rhythm at which time flows decreases, their light takes, for example, at first 1 hour to reach us, then 2 hours, then 3 hours, and we have the impression that they are all moving away from us, and one from the other, like the starting point of the car. The universe then will appear to expand, like a surface of a balloon, despite the fact that now we know that it's not moving at all. There's more. The closer you are to a star or any other source of radiation, the higher the heat and the energy, so the rhythm at which time flows is even lower than in open space. On the other hand, the universe, on a large scale, is isotropic. In other words, the universe is the same in every direction we look at it, like a desert of sand. If we walk 10 kilometers in a desert, no matter which direction we take, we find approximately the same number of grains of sand. the double of that number if we walk the double of that distance. And the same goes for the universe. So the farther a star is away from us, the more stars and galaxies there are between us and that star. This means that the light of that star on its journey in our direction crosses more regions where the time slows down. It takes longer than to reach us, giving the impression that the star is moving away from us even faster than expected. That star and all the other galaxies and objects in space. However, a universe where the time flows slower when energy increases does not expand, nor its expansion accelerates with distance. It looks that way, but it's not. Such universe is steady. It's just the time in space that flows more and more slowly.